Hey, good evening, Nikhil and Suhasini. You just wait for a couple of minutes and we'll start, okay? Can you hear me?
Yes, sorry.
Okay,
Okay.
just wait for a couple of minutes, huh? Think people are joining.
Yeah.
Okay, anyway, we'll start. Maybe others may join. I already posted in the group. I think Suhasini, you already part of the other classes, but this is today is the introduction class, which you may already attended, but it will be a refresh for you. And Nikhil, this is for the first time, right? You are attending a Snowflake
Yes,
class? Okay.
yes.
Okay. So what is the background, Nikhil? Can I ask you?
So master's information technology,
Okay. So you are
IT.
okay. Just
Mhm.
uh,
Mhm.
you just finished your graduation, correct? No?
Yeah, like on December, no.
Okay.
Almost 7 months back on December I've done.
Okay. Cool. Cool. And just to like give a like heads up, right? This is
Mhm.
basically the Snowflake data engineering training. Uh, Let me share my screen,
Okay. Mhm.
and you would have got some reference from who referred you? I just want to. I'm just curious to know.
Soumya. Soumya referred me.
Okay. Okay. So I know that. Yeah. Yeah. Got it. Okay. I'm just sharing my screen. Let me know you're able to see. You're able to see my screen, right? Is my screen visible?
Yes, yes.
Okay. So when I talk about like Snowflake, right? Snowflake is a cloud data warehouse. But before going to Snowflake, let us understand what is a conventional data warehouse and how this has been converted to a like a big data warehouse and then into big data lake and then it moved to the cloud like data warehouse and cloud data lake. So now you can see most of the people talking about data lake or delta lake. So there are so different terminologies coming into the market. But how this particular like data warehouse has been reached this stage? So if you go and see the conventional data warehouse, when you see in the early 90s, when people were very busy in building databases, because before 90s there was no database at all. There were databases and very like initial databases which are like small case databases were there, which are basically people were leveraging to manipulate their data. Like DBase is the first database in 80s, which came into the market, and even before DBase came, people were managing in the form of files, and then people started finding some difficulty in extracting the data from different files. So they started thinking like, why can't we go and build a database to store this data and then retrieve them later and manipulate them if needed. So DBase is the first database which came into the market, and that became slowly, which was a command interface, which is slowly upgraded to graphical user interface, and it has been renamed to Fox Pro. And this Fox Pro was very famous in the banking sector, where companies were majorly focusing on how to go and manage this data, especially banks were using Fox Pro as a database, and slowly that has been upgraded to Visual Fox Pro also. But whenever Oracle came to the market in 90s, slowly it like captured the market, and Fox Pro went behind, and slowly the market was like captured by the entire market, like Oracle and other databases, and Fox Pro slowly vanished. And if you see here, along with Oracle, we were also able to like manage the data using other databases such as MySQL, Sybase, and there was also database like a SQL Server. These kind of databases were very popular. All these, the main object of these databases is to store the data in the form of rows and columns like tables, and build a relation between the tables also. And slowly, the database has been managed by a software called Database Management System (DBMS), and where Foxpro was also DBMS only. And slowly, the DBMS has been converted into RDBMS, where Oracle is a RDBMS, Relational Database Management System, which slowly captured the market by giving the additional security, data protection, all these features. And along with the success of Oracle, we got SQL Server also in the market, Sybase, MindScale. Many other databases also came into the market, and slowly they captured the market as well. And as soon as people started leveraging these databases up to 2000s, every company's objective was to how to normalize this data, divide into multiple different tables, and store in the form of rows and columns, and build a relation between them and use them for the application development. This is what every company was doing. As soon as the industry reached to like the 2000 decade, in 2000, the year of 2000 or 90s, end of 90s decade, people started thinking like how to analyze the data also. So everybody was success to store the data and manipulate it, but how to analyze the data, that is what the challenge. So everybody started thinking like how to analyze the data, but the real time environment was not supporting because the data will be keep on changing. So that is where everybody started thinking like, why can't we go and use a separate database and store the only historical data, and let us call that as a data warehouse. That is where the conventional data warehouse has been born. And slowly the RDBMS like Oracle and SQL Server, these databases were became what became the storage for this data warehouse. And to refresh or build these data warehouses, we got tools such as Informatica is one of the popular data warehousing software, which will perform the extract, transform, and load, and very popular. And data stage also IBM side, one of the tool which became famous, and SSIS from Microsoft. All these softwares slowly captured the market in the ETL space, and these tools helped the teams to manipulate the data, extract, transform, and load into the target from the source. If my source is, for example, a set of flat files, all these files we can integrate by using Informatica and then transform them and load into the target environment. My target can be again any database. It can be in a Oracle data warehouse, or it can be a SQL server or Sybase, whatever it is. But that will be called as a data warehouse. So a data warehouse represents which will store the data. That too, past historical data only, not present data. So slowly, as soon as the data has been centralized into data warehouse, we also experienced the reporting tools also, like business intelligence tools like Crystal Reports was very famous that time. Business objects, MicroStrategy, and SQL Server reporting service. All these tools also have been invented to generate reports on the data which was centralized in the data warehouse. So the data warehouse people used to create using Informatica and Oracle. And finally, once my data is available in the data warehouse, these reporting tools people started leveraging to extract the data from the data warehouse and generate the reports. The main objective of the building the data warehouse also is to finally use the data for generating the management specific reports. And what were the sources for this conventional data warehouse? The internal products and the CRM applications of the company, because every company wants to centralize in their data into their enterprise level data warehouse. So the source data also was coming from the company's information only. And what were the structure of the data? The structure of the data was only rows and columns. There was no any semi-structured or unstructured data during this time period. Only structured data was there, which is in the form of rows and columns, where people used to store in the form of tables. And which were the tools very famous that time? Oracle with PLSQL and SQL Server with TSQL. These two databases were very popular. And these databases helped to load the data in the form of like batch data loading. Batch means what? Your data will be loaded into the data warehouse after business hours by scheduling some time. So every day at 9 p.m. after my business hours, the data from the real-time environment will be collected, extracted, and it will be transformed and loaded into the target data warehouse. That is what people used to follow. This is people used to call as batch process. And then once after the data has been centralized in the data warehouse, every company started building their own products, like revenue leakage analysis, potential customer listing. Most of these applications also started generated by the companies. So these products started helping the companies to take some appropriate decisions according to the analysis they performed. So this is about normally the evolution of conventional data warehouse. If you go to the like 2010, there was a sudden data growth in 2010 decade. In that we see in 11-12 year, there was a sudden data growth and suddenly data got increased. And we also experienced some sort of unstructured data and semi-structured and quasi-structured data also this particular time period after 2012, because there was a valid reason for that. Can someone tell me what was the reason for sudden data growth in 2011-12? Anyone? What was the reason? Any idea? What was the main reason for high data growth suddenly? Anyone? Suhasini or Nikhil? Pujita? What was the main reason for high data growth suddenly? Any idea? Hey Dev, good evening. Am I audible? First of all,
Yes, yes, sir.
yeah. So my question is, why there
But
was a sudden data growth in 2011, 12, and 13? There was a valid reason. You may also experience that. Any idea? You can guess it. You can guess it. It does not require correct answer.
social
Hmm.
social media platform.
Correct. Correct. Very good. Social media. 100% correct. Suddenly, what happened? We got Facebook, right? In 2005, 6, and 7, as Facebook has been started, they started giving privilege to store videos, images, and upload videos and documents and all this stuff. Suddenly, what happened? The data growth suddenly increased. Most of the unstructured data also people started generating. Not only Facebook, right? Other, because the success of Facebook, what happened after? We got LinkedIn, YouTube, WhatsApp, Instagram, Twitter, many different like applications, social media applications got emerged and they became the reason for the high data growth. And most of the unstructured data got generated after 2012 only. Before that, there was no unstructured, there was, but very, very limited. So then people started thinking, because if it is structured data, we can manage using databases like Oracle SQL Server, but it's a unstructured data. I cannot store in databases because that will become a contradiction. The main objective of database RDBMS is to divide the data and store in the form of tables. That too, it requires in the form of structured form. Structured form means rows and columns. So when companies started thinking about how to manage this data, that is where big data frameworks came to the market, like HDFS, MapReduce. These two became very, very popular. Both tools became very popular and they started became one of the popular frameworks for storing the big data plus processing the big data. HDFS for storing the data, Hadoop distributed file system, and MapReduce for processing the data which got stored in the HDFS. So both frameworks were very popular. Even I switched to big data during the time period because I learned HDFS, I learned MapReduce, I learned some big data frameworks so that I want to become a big data engineer because that was the like hard skill that time. Even I got to learn because of my project demand. When I was working with MasterCard, I learned these big data tools and I worked on migrating the traditional conventional data warehouse to big data warehouse. And slowly, the MapReduce was popular only, but it was having some limitations where you can't go and manage live streaming data. Plus, also you can't. The MapReduce used to take hours and hours to process the data. because MapReduce will work on the disk rather than memory. It will go and pull the data from the disk and process it, and again it will go and go, go and store the process data in the disk again. So this used to take so much amount of time. So companies used to experience so much latency, but since there was no choice, people used to use the same. Whenever Spark came into the market, which is a in-memory like distributed computing engine for large-scale data processing, the all the limitations of MapReduce were like rectified in Spark. Spark slowly replaced MapReduce, which is a single unified framework for multiple different tasks. It can process structured data, unstructured data, semi-structured data, any kind of data. And before Spark was there, people used to use different frameworks for different purpose. But after Spark came to the market, slowly all the other frameworks got vanished. Scoop was there for structured data processing. HBase was there for NoSQL data storage. Uzi was there for scheduling. But most of the frameworks, Storm was there for real-time processing, structure like streaming processing. But Spark slowly replaced all this. The Spark is a combination of multiple components which can help to implement the same whatever we can perform in the other frameworks. And after big data has been like warehouses have been created, because of the success of this big data, the new tools also came into the market which can process the big data, like MicroStrategy and Power BI. These two tools also became very popular because to process huge amount of data, that too semi-structured and unstructured data also, we need separate data like business intelligence tools. Normal existing crystal reports and other tools were not suitable. So that is the reason these new two tools like Power BI, Tableau, ClickView, MicroStrategy, all these tools came into the market and they became the popular business intelligence reporting tools also. But coming to the sources of the data, after big data came into the market, we got not only internal data, social media also became the part of the sources. You might have seen some applications like sentiment analysis. So to build these kind of applications, I need some social media data also. So I need to go and process the social media by directly connecting to the social media applications like Facebook or Twitter. And we can go and see how my customers are like talking about my products in social media. So social media became one of the biggest source for processing and to manage the data. So the data format also structured, semi-structured, quasi-structured, and unstructured. These are the popular formats after big data came into the market. And what is the required knowledge? So the required knowledge was to work on this big data environment. People used to learn is Java. Java was the first language which was very popular after big data became famous. And not everybody is interested to learn Java, so some people started learning Scala also. And because we can implement MapReduce like data pipelines to processing data pipelines by using Scala also, Spark and Scala. But after some time, what happened? Scala also slowly became obsolete now. Python came to the market with Spark and PySpark with big data. HDFS is the popular combination now. If you know PySpark and if you know like what is big data and Hadoop and a little bit about Hive framework, you are the topmost. That is what people are looking for in the big data side now. And what was the data loading frequency? Before this 2010, the data loading frequency was only batch processing. So companies used to wait till the daily transactions to complete, and after business hours, they used to go to the real-time environment. They used to extract that, transform it, and load into the target. So that is what happening in the batch processing. Whenever people started thinking about live data capturing, that is where big data frameworks like Kafka came into the market. Storm, Apache Beam, and these are all part of real-time data processing. And the same frameworks can be implemented in the AWS side with Kinesis also, AWS Amazon Kinesis. That also will give the same solution to process live streaming data. So why I need to go for live streaming data? There are some applications which you want to build. You need live streaming data also. Example, credit card fraud detection or money laundering detection in a transaction. I cannot wait and to get a confirmation about my money, any money laundering transaction, and nobody will wait, even for credit card fraud also. I cannot wait for 1 week, and I can go and confirm a customer transaction is a fraudulent, because the fraud can happen anytime. So someone may hack your credit card and they might be using, and they might be swiping. Suddenly if it happens, so you under which is not under your control. So you definitely need to reach out the bank to block your card. So that is very important. So to build such kind of applications, I should be able to capture live streaming data. So that live streaming data can capture to capture live streaming data, I need to depend upon the framework such as Kafka, Flink, Storm, or Apache Beam in on-premise, and in the cloud you can use Amazon Kinesis in the AWS side. Example. So all these frameworks will help you to process live streaming data, and where I can do data loading frequency now became after that batch and live. And what kind of products companies started building after like using this live streaming data? Recommendation systems and fraudulent transaction detection systems. So how many times like you visited I hope everybody visited Amazon, frequently use Amazon. In Amazon, how many times you received a recommendation after you bought a product? Every time you will receive a recommendation, right? Before you are going to pay the money, everyone. It happen or not? My question. When you buy any product in Amazon website, before you are going to pay the money, you will receive a recommendation from Amazon. Why can't you buy this product along with this product you are interested? Is this going to happen or not? My question. Nowadays. Yes or no? How many times you received a recommendation? My question. You need to answer.
Yes, every time we get that recommendation.
Correct. No. Why the recommendation is coming to you only? Did any time you had a question in your mind?
It takes our cache and do some analytics and recommend the products.
Very good. Correct. So there is a process will have which will run in the background. Whatever the actions you perform on any website, right? Any e-commerce website, for example, since we are talking about Amazon, Amazon will try to capture your actions, which pages you visited, how much time you were there in that page, which products you selected, and all your information they will capture in a clickstream file, which is called quasi-structured data, which is one type of data. That data they will try to analyze. They will try to extract some of the important information by leveraging some text mining, like NLP, and they will try to see which products you selected. For example, I might have selected electronic goods, so they will try to recommend me electronic goods related products, and you might have selected some part of books, so they will try to recommend you some books. So according to the customer interest, they will try to analyze, and these recommendation systems are started giving increase in the revenue, because when you recommend something, the customer may buy. There is a high probability if they are interested and you give some discount, they will definitely buy. So that is what every business started. Not only Amazon, if you go to any other domains, banks also are doing that. If you go to even online training institutes also doing, when you are buying a course, they will cross sell some other courses. So that cross selling will happen only when you go and use this particular recommendation systems only. So to build this recommendation system, I need a real-time data, live streaming data. So normal big data warehouse only capture the past data. So if at all I want to build this kind of recommendation systems and credit card fraud detection systems, can I wait for 1 week, and so that the bank will come back and tell me there was a fraud transaction happened in your credit card 1 week back? Nobody will accept it. Nobody will accept, and immediately they will ask, why didn't you block the transaction if you know it is a fraudulent? Why are you waiting for 1 week? That is what the question every customer will raise. So to block that transaction, the bank would have restricted the transaction by capturing in the live data. Whenever the particular person who is misusing my card, then whenever they will swipe, the bank has to cross check the transaction, and we should have a system which can go and mark that as a fraudulent if it is a fraud. So that is how we can manage the real-time systems or real-time transaction detection systems by leveraging the data lake here. So data lake represents a data warehouse is a historical data, but data lake will have both historical and live streaming data. And a data lake is basically can hold any kind of data, structured, semi-structured, quasi-structured, and unstructured. But data warehouse will only keep the structured data. So data lake is one single location, centralized location where you will see all kinds of data with high data volume, high velocity, and different varieties. All this will happen in the big data warehouse and big data followed big data lake. So when you talk about all this big data environment and big data lake and all this stuff, so every company was happy. So they were able to manage. They got a solution, but there were some challenges for a data warehousing technologist to go and migrate into big data engineering. Even I was facing some challenge too while I'm learning. When I was learning this particular framework, there was a high learning curve, and you should also should have you should have an interest in learning all this. But not every data warehousing engineer will be interested to migrate to big data engineer, because you need to learn so many frameworks. If you go and see, the traditional data warehouses will have so many challenges in general. Okay, infrastructure as a service, one biggest challenge. I need to maintain my infrastructure, and all infrastructure need to be separately. I should have a dedicated team to maintain it. And a limited storage capacity. Your storage also will be restricted. If the data volume keep on increasing, your data warehouse cannot manage that. Assume my data warehouse capacity is 1 terabyte and it is already full. Suddenly any additional data comes, my data warehouse cannot store, and it will be down. So I should consider the capacity, storage capacity also one of the biggest factor, and high cost. So to store more data, we need to buy more storage, and the cost also will be very high. And limited processing capability also. When I talk about high volume of data, big data warehouse or data warehouse can do that, but we also need to understand what is the infrastructure required to process that much amount of data, and with that much high velocity with different varieties. All this cannot be done with the normal traditional data warehouse, because traditional data warehouse is designed for only structured data. That too, it has some limitation. No scalability. Scalability means what? Suddenly, if my data warehouse requires additional infrastructure, normal traditional data warehouse cannot help us. But in case of big data environment and specifically cloud data environments, we have like scalability is one of the biggest benefit. If you go to AWS, the AWS can help us to go and migrate your like existing infrastructure to additional infrastructure also it can provide us. You can easily go and scale up and scale down when it is required. Maybe my application requires additional like servers, because maybe on festival season I am experiencing high floating of users. So suddenly what happens? The people will, whenever they visit, they will experience some downtime if we don't have additional memory or additional CPUs. So we need to have a additional infrastructure which I can easily add and easily release. So only for the 1 month or December and January, I need additional infrastructure. So I will go and use whatever the cloud provider is offering us, and later once our job is completed, we can delete them. So this particular feature not available in the traditional data warehouse. We need to depend upon the cloud data warehouses only, because they will provide automatic scaling also. and failover and replication. So failover replication will happen whenever some disaster will happen. So disaster means what? Whenever you go and see suddenly a particular machine is down, the database is down, the application will go down in the normal traditional data warehousing environment. That will happen because every application will depend upon the data warehouse or database. But in case of database failover, normally with the cloud data warehouses, you will have a additional nodes which can provide the additional capacity and additional storage without any downtime also. So failover and replication should be automatically happen for any kind of data warehouse. And data security also one of the important factor, because customer data is always sensitive. I cannot go and share my customer data with everyone. So a particular data warehouse software should provide a feature for masking the data and sharing the data in a secured and protected way. So existing data warehouse tools are not supportive. You need to write our customized code also. We go to Oracle, we don't have any built-in data security features. You need to write, if at all I want to mask the data, I need to use a masking policy which I need to customize and write it and build it. But coming to Snowflake or other cloud databases, you will have the data security feature inbuilt. You simply need to know how to use it. That's about some of the challenges with this traditional data warehouse, and all these challenges can be easily overcome with the big data warehouse and then big data lake. But the challenges of maintaining is also one of the problem for the companies, and also learning is also one of the challenge for the developers also here. So I can maintain because I have so many frameworks. We can see so many frameworks here. Every framework is part of big data here. Like MapReduce, we discussed about HDFS to store the data, MapReduce for processing, Apache Mahout for machine learning, and Spark MLlib for again machine learning, and Pig, which was very famous for data processing, and HBase for storing the unstructured data, and Apache Uzi for scheduling, and Apache Ambari for providing the resources and coordination and orchestration, and Yarn for resource management. But most of these particular frameworks, 90% are not available now. All became obsolete because of cloud infrastructure is available now. We observe here, MapReduce got replaced by Spark. And Apache Hive is there, but some companies are using, but Strom is not there. But some people are using Kafka. And Mahout is already out. But Spark MLlib is very famous now. So Spark replaced in many places. So this Kafka also, some companies use Spark streaming. So you can see here, from here, 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 and here, and even for here, Spark is managing for most of the cases. So all these frameworks got replaced by Spark now. And Yarn with HDFS and Spark is the popular combination now. And Flume is also not there. Scoop is also not there. So all these frameworks slowly people started people stopped using them because Spark is one of the popular framework which can do anything, whatever these particular tools can do. So slowly because during this time period of 2011, 2013, everybody was facing challenges because to learn these many frameworks, it was not easy. For a data warehousing engineer, if I ask you to learn these many frameworks, will you be ready? No, right? Nobody will be ready to learn these many frameworks. And I want to become a big data engineer, that was the fact. Even I learned most of these frameworks except one or two. I know all these frameworks and I worked on this all also. Only I never worked on SOLR, but I worked on all the other frameworks while I was majorly working on MasterCard data warehouse, where I migrated the existing traditional data warehouse to big data warehouse and then big data lake also. So I got to use all these frameworks because there was no choice that time. I need to go and learn, I need to go and implement. I faced so many integration challenges and successfully I migrated also, but that was not happen in one day because the learning curve was very high and not everybody will be interested to learn this particular big data tools. Second thing, for companies also, there are so many challenges because companies, if at all they want to maintain this big data environment, big data ecosystem is very, very fragile. You can't go and maintain that much easily because patching, upgrading, all these are majorly like can happen, but that is the company has to take care with a dedicated team, and performance requires manual intervention. Finding a technical resource is also very, very difficult. Who knows these many frameworks? And managing the Hadoop cluster. See, if at all you go and see, in 2012-13, there was huge demand for Hadoop administrators because people who knows how to manage big data environment, companies, every company are looking for such kind of people. But that is not easy also because a person who wants to become a Hadoop administrator should be before a Linux administrator. So not everybody can become a Hadoop administrator. Even now, you should have a background of networking and also like Linux administration because most of the big data environment need to build on the Linux environment. So finding a technical resource is huge, like giving and even huge salary how to pay them. They're very costly, high demand for them that time, and we can't reuse the people who are already working in conventional data warehouse because not everyone is interested. Correct, no? When I go and ask someone to go and become a big data engineer, they may not be ready because they will be afraid of learning this many tools, first of all. So that is what happening for developer level and company level. Developer were hesitate to learn, and the companies also were not able to manage this much amount of data, and they need to have a dedicated teams. And coming to like traditional data warehouses, these were the challenges. But how Snowflake is now helping? Snowflake basically is a cloud data warehouse. Whatever the challenges the traditional data warehouse were experiencing, all these can be like we can overcome by using the cloud data warehouses. In out of these cloud data warehouses, Snowflake is one. We have Redshift, we have a BigQuery. So these data, these are also the cloud databases, but Snowflake is a bit popular out of all this because of its unique features. Because Snowflake is a cloud data warehouse, which is very simple. You can go and it is built on top of cloud. We do not need to install anything. Simply go to Snowflake website, create an account with your email, and then once after your email is registered and your account is they will send an email, and that email you need to click on and activate your account. During the activation, they will prompt you to create your username password. Within 5 minutes, you can finish creating your account and you can start using it. But this is not the case for building a big data warehouse in on-premise. There was a huge challenge and so many steps we need to follow to build a big data warehouse, and you cannot even manage them because we need a dedicated team who are strong in that area. So that is what the challenge every company was facing. And coming to like cloud data warehouses, they are cost effective, easily accessible from anywhere, any device, anytime. And also scalability is one of the biggest factor. And Snowflake, Amazon, Redshift, and Google BigQuery, all these are fall under this particular cloud data warehouses. The benefit with all these like cloud data warehouses is flexibility is one where I can go and immediately start creating an account, and within 10 minutes I can start using them. Cost savings, as I mentioned, accessibility, all these three are the very important factors. All these will provide a pay as you go. Why Snowflake is popular is because of pay as you go, also one of the reason. We can use it and we can pay. And Snowflake, when compared to big data tools, why Snowflake is very popular is to learn big data, I need to know Java, Scala, Python, all this, any kind of these languages. But for Snowflake, if you know SQL, that is more than enough. You do not need to know anything extra. If you know SQL, you can easily learn Snowflake, and you can also go and see if at all I want to go and work on any extreme use cases, we use Python, not for every use case. And Snowflake, like normal big data environment supports semi-structured, structured, and unstructured data. Even Snowflake is they are supporting the structured, semi-structured, and unstructured now. Earlier they were not supporting. Now you can manage any kind of data in Snowflake also. And live streaming data processing easily we can do in big data using Kafka. I can also use Kafka in Snowflake, and we can connect using Kafka connector, and I can process the live streaming data. And Snowflake also now they added a feature called Snowpipe streaming, which can be used for the live streaming data. And the stability of the product, if you see, the big data ecosystem is very fragile. It will be keep on changing, so you will definitely experience some challenges whenever you perform any upgrade and patches. And you don't even know how to sometimes resolve the issues also, because most of the code will be in the Java. You should know Java specifically for that. And coming to like uh, Snowflake side, everything is integrated in the single product. So you do not need to worry about how to maintain it and how to, and you can experience any kind of issues that is not your problem, because Snowflake team will take care of all the patching, upgrading, and the provisioning everything. And any performance optimization required in the Snowflake side, everything is inbuilt, but in the big data side, you need a manual intervention and you need to optimize the performance of the application. And the data transformations, if you see any data warehousing project, extract, transform, and load. In the transform phase, you apply some transformations. I apply a filter transformation on the raw data to only select some set of rows. Or I'll go and join two data sets or a table and a file, and I'll get a joined data. That is a joint transformation. So transformations in a big data side, I need to write some coding here like PySpark or any kind of Scala coding, and I need to apply transformations. But in case of Snowflake, we already have tools in the market like DBT, very popular data build tool. And Informatica side, we have ISS and Matillion, StreamSets, Fivetran, ColicTL. Most of these tools are helping to apply transformations directly on Snowflake data. How Informatica, Oracle were famous earlier. Now, Matillion and Snowflake, or DBT and Snowflake, or StreamSets and Snowflake, or Fivetran and Snowflake, or ColicTL and Snowflake. These are all the popular combination now, because they will allow you to process Snowflake data from their environment, and they will allow us to create data pipelines by extracting, transforming, and load directly on the Snowflake data. So that is why Snowflake is very popular. And what is the supported size? Supported size in Snowflake, we have like unlimited data. Even in big data side also unlimited, but sometimes it is restricted also. Only in the cloud side you will experience if my big data environment is in the cloud, so then you can experience unlimited. But normal on-premise, you need to have a limitation. And resource availability, if you see, big data side, it is not easy to find. Who knows these many frameworks? Very hard to find and train. But in case of Snowflake side, you can easily train, because Snowflake people who knows SQL, I can easily train them. So 90% people will learn SQL very easy. If you know SQL, you can easily learn Snowflake, because most of the Snowflake code will be in the SQL, like ANSI SQL. And even salary is also extremely high for both big data as well as Snowflake, almost same. And use cases wise, Snowflake supports both real-time systems like, as I mentioned, recommendation systems and batch systems also. But big data is only designed for real-time systems only. So companies are looking for one single unified environment to perform all this in one place. That is where Snowflake came to the market. So when I go back and say Snowflake, why people are going to Snowflake is, first reason is simplicity, and which is very simple, serverless and plug and play. I can create Snowflake account within 2 minutes and I can start using it. And scalability is another feature which I was talking about. Any amount of data I can scale up to. I can scale up to any number of users and any amount of workload. And Snowflake also provides us the elasticity feature. When you want to run any SQL query in Snowflake, you need to have a compute. Compute means resources. This compute and resources will be provided by the a feature called component called virtual warehouse. This virtual warehouse is a nothing but a group of cluster, and again a cluster is a group of machines. So to run your SQL query, you need a virtual warehouse running in Snowflake environment. When it is running means every query will go and use resources provided by that virtual warehouse, and every virtual warehouse will have some size, like our t-shirt size, small, x small, x small, small, medium, large, x large, like that. So all these will happen. Whenever you want to go and increase the size, you can increase. But in the normal traditional databases, whenever I want to increase the size of the database, I need to stop the entire database. But in Snowflake, I do not need to stop anything. Even my queries are running, I can increase the size of the warehouse. I can decrease. I can do anything, even the queries are getting executed. So because storage and compute both are decoupled here. And Snowflake also provides with a flexible cost, because we can pay, we can use and pay, like pay as you go, like our credit card or postpaid connection, how you pay. Similar to that, Snowflake is allowing the customers to use and pay. Like AWS also do the same, Azure also do the same. You will use and pay. But Snowflake is specifically designed for the database or data warehouse management. So you will experience the cloud database features. And diversity is also another important feature, where you will have one single location where your data will be stored, even if you load from anywhere. And anybody can access the data from any location by using any device. So Snowflake is basically, we can call it as a cloud data warehouse, which is basically a software as a service designed for the multi-parallel processing, and then which is a data platform and a cloud platform agnostic, because I need to select one of the cloud while creating a Snowflake account. It can be GCP, or it can be AWS, or it can be Azure, whatever it is. When you are creating your Snowflake account, it will prompt you to select one of these, and you need to select of your choice, because this cloud will be used to maintain your environment. If I select AWS, Snowflake will maintain your data in the S3 bucket. If I select Azure, Snowflake will maintain my data in the Azure Blob Storage. When I select GCP, Snowflake will maintain my data in the Google Cloud Storage. And compute will be maintained according to the cloud also. Like if it is a AWS, my virtual warehouse, which is a group of machines, will be maintained using the AWS EC2 instances. If it is Azure side, it will use the virtual VM instances, and for Google side, you'll have a Google Compute. So the respective cloud, whatever you select while creating the account, that will be utilized to maintain your environment. So, but you need to cross check before getting account which environment your company is already having an account in AWS in the cloud side. If your company is having AWS account, and you should not go and select Azure while creating the Snowflake account. If it is AWS, use AWS only. If my company is in Azure, use Azure as your cloud selection while creating the account. That will save your time and cost also. And coming to like other features, Snowflake advantage over on-premise is like it is a true software as a service, and scalability is one feature. Availability and security is another feature which we discussed, and fast data retrieval, and flexible charges with pay-as-you-go, and zero maintenance and management, because all the maintenance will be taken care by the Snowflake team. And also cloud advantages, whatever the advantages every cloud is providing, Snowflake also will provide that. And seamless collaboration and data sharing. So I can share data from one Snowflake account to another Snowflake account also, which is not possible with other applications. And near zero downtime. So you never experience downtime in Snowflake environment, because both data and compute are not combined, both are decoupled. And one more interesting feature in Snowflake is time travel and failsafe. The time travel feature will help you to restore the data even if you deleted data permanently. If you go to normal databases, if I drop a table, table name, I cannot get it back. Did anytime anybody tried dropping a table using drop table name in any database? Yes or no? When you drop a table in Oracle, can I get it back? My question. Drop table, table name. I fired this command. Drop table customer. Can I get this table back after I drop it? Provided I don't have any backup.
No, without backup, no.
I don't have any backup. So if I dropped it, even my DBA can't help me. But in Snowflake, we have a feature called undrop table, table name. Immediately, even if my table is billions of rows, within fraction of seconds, it will restore and give me. Even if you deleted any rows, maybe 1 week back, I can go back and get them back. Even if you deleted and even you committed it. Commit means you saved it permanently. This cannot be done in other databases. But there is a tedious process for DBA also to go and restore them. But in Snowflake, it is very easy. I do not even need to depend on any DBA also. I myself, as a developer, I can go and restore it. That is the main benefit with the Snowflake time travel feature. That is one of the reasons why Snowflake is very popular. And all these features, whatever you see, these are all the common Snowflake features, like pay as you go, optimized storage, where Snowflake data will be stored automatically, compressed and stored, and caching. Snowflake provides one feature which is basically will help you to save your compute cost by using the caching, where your query results will be stored in the query cache and will be available for 24 hours. So I can reuse them, and every time when I run, first time the query plan will be generated, and once your results are ready, the result will be stored in the query cache, and second time onwards, the results will be selected from the query cache without using the compute, and that will save your cost also. And cloning. So if you go to normal traditional databases, if you create a particular production database, and to create a backup of the production with the development, and assume my production database 1 TB, to create the development database and one more testing database, I need to have two additional storage of 2 TB extra. Then only I can create. But in Snowflake, I do not need to go and create a physical database. I can use a cloning feature which can help me to create backup database with additional storage cost. And it also provides some semi-structured data processing also, which is not available in other databases, like JSON processing, Parquet processing, many different file formats available to process it. And as we discussed, the time travel and failsafe is also one unique feature available to restore your deleted data. And data sharing is one of the unique feature available in Snowflake to share data with other Snowflake accounts. And replication, database replication also can be done to save your like business continuity when some disaster will happen. And finally, serverless features are available where you can go and run your like development activities using serverless features, and all these features will speed up your development activities. So search optimization service, and then automatic clustering, and the methods we use, and all this will help you to speed up your query extraction speed, and you can experience some optimization also, performance optimization. All these features are making Snowflake unique in the market. And coming to like other features, like how to go and create a Snowflake account, we'll see. And Snowflake architecture wise, we'll discuss about that maybe in the next class in deep. It follows a shared disk and shared nothing architecture. Shared disk means what? The data in the other database, if you see, that will be shared by multiple like clusters here. If my storage is this particular mission, is the storage disk is down, all this will be down, which is not correct. But the modern databases are following a shared nothing architecture. So every mission will have its own storage. So even one mission is down, you will have other missions which can provide the data. But this is not same for Oracle or SQL Server, other databases. They use this method. So this is down, all this will be down. So that is what normally will happen. So disk storage, this is the shared disk. If this is down, all this will be down. But in case of Snowflake and modern databases, every disk will have system will have a storage, disk storage. So if this is down, no need to worry. You will have this two will be available. So like that, shared disk and shared netting architecture is very commonly used feature in the modern databases. So Snowflake also follows a shared disk hybrid and a shared like nothing architecture, a combination of multi-cluster architecture. So it will create a it will help us to create a virtual warehouse with multiple clusters, and so that I can manage my data and also my query execution speed faster. So Snowflake comes with a three-layer architecture. First one is like a cloud services layer, the green one. Second one is query processing or compute layer, and third one storage. So the first one is responsible for your authentication, where you go and log in and enter username and password. You will connect to this particular layer only, and this particular layer will not only allow you to authentication, it also will help us for metadata management, transaction management, query plan generation, and infrastructure management and optimization. Most of the activities will happen, serverless features will happen here. And any normal development operations we want to perform, compute layer will help us. The compute layer, which will have the virtual warehouses, will allow us to run your SQL queries. So whatever the query I run, that query will be executed under this layer only. All my SQL activities, SQL statements will execute under second layer. And this layer requires a virtual warehouse to be running. If there is no virtual warehouse is available, your query will not going to execute at all, because it requires resources. And whatever the data you are going to store in Snowflake will be stored in the centralized storage architecture. This is the storage layer. So your data will be maintained in the cloud environment. If it is a AWS specific Snowflake which you registered, so your data will be maintained in the S3 bucket. And your compute warehouses will be maintained using the EC2 instances. If it is Azure environment, your data will be maintained in the Azure blob storage, and your compute will be maintained using the Azure VM instances, like that. So for GCP also same. This will be in the Google storage, and compute will be Google compute instances. So any cloud you select, that will be maintained accordingly. So this is a high level architecture we'll discuss in detail. And most of the features, whatever you see, these are making Snowflake unique in the market. And Snowflake is basically one of the cloud data warehouse very popular because of all these unique features. If at all I want to create a Snowflake account, it's very easy. So you can follow a step-by-step approach where you can go and start using. Let me show you the account setup. Whatever I need to go and log in into this URL, whatever you see. If I go and click on this URL, it will redirect you to Snowflake environment. So here you can go back and see it is clearly showing a 120 days free account, but normally you can't create like this. But if you go with a normal approach, you can only create a 30 days account. This is another URL which we can use and create a 4 months account, free account. Normally, if you go with Snowflake, for example, if you go to normal approach, if you go to Snowflake free trial, see what happens. We saw 120 days, but when I go with Snowflake free trial, you need to see how many days it is showing us. How many days is showing? How many days? Everyone. 30 days only, right? But what happens after 30 days? I can create one more account, but I can use the same email and I create one more account, but I need to create new account after 30 days. Or I need to upgrade my account by paying money. Since you are learning, you do not need to go and upgrade it. You can get one more account if you are okay. So you will just lose the data. You can get one more account with the same email and you can use for one more month. But every month you have to create. If it is a 30 days account, what if I want to go with a 100 days account? A separate URL is there. We'll go with that. And that particular URL will allow to create a 100 days account. So I will share this link, which you can also create. And once after you came to this particular page, you need to understand this is a 120 days free account and $400 free credit will be available. So this is not like Snowflake is not going to charge anything. They will not ask you to any credit card details, anything. They will just ask you your email. That's it. So give your details. So you can give your email, any email, whichever you want. Just click on personal learning and development and click on continue. And here you can give any name. There is no restriction. And select one edition here. Here edition represents what Snowflake is providing, that edition which we need to go and use it. So Snowflake will provide 4 different editions. One edition will not be visible here. Standard edition, enterprise edition, and third one, virtual private edition. So we need to go and leverage one of these editions. So according to your choice, standard is very basic level of edition. Enterprise is the next level of edition, and business critical is basically will have additional features compared to enterprise. We'll discuss about all this in the next class, but as of now, I'll select only enterprise. And cloud also, we can select anyone. I'll select AWS and I'll click on this checkbox and then click on get started. So they will show some security check. You can just go and select that. Man. Right? Why is not moving? Perfect. Okay, I'll skip it, and this is creating. So my account has been created. So they will send an email which we need to go and log in and see. Open your Gmail which you added here, and in that Gmail you will receive a email to activate. So they activate your Snowflake account. You will receive this particular email. So you need to click on this, and you need to keep this URL handy. This URL is very important. This URL is going to your unique identifier. You can see this is your unique identifier. You also will get a similar kind of one. So keep this URL every time while you are logging in. You need to use this URL. And before that, activate your account. Click this, and this will prompt me to enter my username and password. So I'll use my username and password here, regular username, which you can easily remember. Give that, and password also your choice. So, give the regular username and password which you can easily remember. So we have a document on how to create this account step by step with screenshots. I will share that also, and this PPT also contains the steps which you can go through. So this is what my account, my Snowflake account is ready now. This is called Snowside web interface. So in this interface, you can see $400 free credit, which you can see, and 119 days. So total 120 days trial period I have. If I go with normal Snowflake account, you will get only 29 days or 30 days here, but you will get $400. So the benefit with the URL which I am going to share you is you can create a 4 months account also. If you go in normal process, you will only create a 30 days account. Again, every 1 month you have to create. But this method will help you to create a 4 months account. Up to 4 months you can use for free of cost. Only after 4 months you have to get one more account. Now my Snowflake environment is ready. Then how can I use it? So you can go and click on projects, and here you will see worksheets, and these worksheets are nothing but the SQL worksheets. So Snowflake will allow you to run your SQL commands on the SQL worksheet, and you can also write Python coding in the notebooks also. So Python coding also I can write. So in the worksheets also I can write Python coding. So you will see a plus button here. I click on this button, you will see two worksheets. One is SQL worksheet, another one Python worksheet. So if I want to run Python coding, I can use Python worksheet. If I want to use SQL, I will use SQL here. So once you click on that, it will open a SQL window. Close this, and here you can see left hand side three default databases Snowflake will create for every account. This is available for even for your account also. These are the default databases. Snowflake is one database, Snowflake Learning DB one database, and Snowflake sample data is one shared database. So this sample data contains multiple schemas with a huge amount of tables. You go back and see the table size also in terabytes. You go back and see the part table. So 10 GB is there. You can also see some tables in the 100 schema. You can see 10 terabytes tables also. If you go and see the store returns, this is 933 GB, and also you can see store sales 10.4 terabytes. So since we can't create sample data with this much bigger size, Snowflake is providing some sample data here. So you can test it, and you can also play with this data, and you can go and experience Snowflake environment also here. So Snowflake is providing sample data to test their environment. So if at all I don't have any huge amount of data to test, I can use these sample tables also. But how can I create my own database? These are all Snowflake created. So to get my own database, simply use a create database. I can create demo. So this is going to create my new database, which you can see in left hand side. If you refresh, you see demo database. So for demo database, these two are the sample schemas by default which will be created. One is public schema, second one information schema. So every database will be maintained using the information schema, where you will see all the views, metadata views to maintain this database, like databases and what are the tables available and what are the procedures available. You will see everything here. So all this will help you to see like what are the different database objects available. You can monitor them. All these are metadata views. You can also see like procedures, packages, and you can see also tables available, columns available. So all the metadata can be monitored using this particular schema. The second database is the public schema, which is default one. This will not contain any tables. You can use this table, this schema, or you can get your own schema also. So Snowflake will allow you to create our own schema. Maybe I want to create a schema with name dev. So dev is on the schema I want to create. So you'll see a dev schema also here, which my own schema. So we can create multiple schemas here, dev, test, QA, like that, and you can segregate your environment also. Now dev schema is created, and we'll go and select some table we'll create under the schema, because as of now I am pointing to demo database dev schema here. So table whatever I create here, that will be created in this particular environment. So create table emp we'll give like varchar we'll give like 30 comma salary float. So this will be created. So table got created. So we go back and refresh, you see a table got created in dev schema with name emp, because I am pointing to dev schema. So my table whatever I created, all the database objects going forward will be created under this particular dev schema only. Even if I create a view, that will be in the dev schema, any database object, because whatever the schema I am pointing to, my database objects will be created under that schema only. So that is how you can go and create a table. I can also insert some data, insert into emp. We can use a regular ANSI SQL only. Values. This is inserting one record. So this is going to insert one record. I can select and see. So this is one record got inserted. I can even insert multiple records also, but I need to use the method of how to insert the multiple records. We'll see that. But this is how you can go and understand about Snowflake at high level and how to create a Snowflake account and how to log in into that by activating, and how to create some sample database and tables and load the data by inserting some data, sample data. So, but if you see in the traditional normal projects, if you go back and see, you will see some data pipelines which you will create. But these data pipelines to create, you should understand the traditional Snowflake features also. One by one we learn as part of this training, and what we are going to cover as part of this training also I'll show you. And these are the projects which I'm going to cover as part of this training, which will help you to create a end-to-end pipeline by leveraging Snowflake and AWS services. And another project with DBT integration with Snowflake, which we are going to learn, where you'll see like some part of DBT, Snowflake, and Airflow integration also. There are some of the sample projects which you can see. And to understand about what I'm going to cover, let me try to show you. So we will like go and start understanding about, just a minute. I think this looks like the old one. Let me try to get. Yeah, this is the correct one only. So we will start with understanding the fundamentals of Snowflake. So where you'll go and try to see, we already learned about what is Snowflake and what is the database and what is ETL and data warehouse and data lake, all this stuff. We also saw how to create a Snowflake free account as well. And but we will need to understand about in detail about what are Snowflake editions, and whatever the environment which just we logged in, that is nothing but the Snowsite web interface. And how to create a database we saw, how to create schema also we saw, how to create a table also we saw. But how to create a warehouse we'll need to discuss. We'll see that. We also need to understand about what is the RBAC. There are some concept called roles available. We'll try to learn about that. And we also will learn about how to create custom roles and how to use system roles and how to control the data access from other users. And also you need to understand what are the different types of accounts available. We'll try to discuss about that. And once you finish that, we'll try to see how Snowflake is going to help us to understand with AWS and S3 integration. Plus, need to understand in deep about Snowflake architecture, a 3-layer architecture. Just now we discussed about the cloud services layer and then compute layer and the storage layer, which we saw. We will see in deep. And after that, we need to also understand as a developer, you should know the understanding of pricing. So how to go and understanding pricing, we'll discuss about, and what is the Snowflake credit and how it will be used to like calculate the cost of your Snowflake environment. We'll try to learn. And what are the different types of cost Snowflake will charge the customer, we'll see data transfer cost, compute cost, and also like virtual warehouse cost, and we'll try to see storage cost. We'll try to see what are the different types of cost one by one. And also we need to understand about Snowflake caching feature, which will reduce this cost. See, when you know how what cost Snowflake will charge you, as a developer, your job is to how to reduce that. So caching is one feature that will help us to reduce the cost. And as a developer, we should know what are the best practices to reduce this. And apart from that, you also need to understand about what is the importance of virtual warehouses in Snowflake and what is scale out and scale up as part of that. Because the virtual warehouse will decide what is your cost involved in your Snowflake environment. So you need to understand that. So once you finish that, you will jump into data loading and unloading in Snowflake. So data loading will happen in bulk loading and continuous loading. We learn one by one. So bulk loading or continuous loading can be done for all these file formats. So 6 file formats Snowflake will allow us: CSV, structured form, and remaining all semi-structured form like JSON, XML, Parquet, Avron, ORC. So we'll try to see how to load every type of file with bulk loading as well as continuous loading both. So bulk loading can be done by using internal stages and external stages both. We'll try to see how to load the data. We need to load using internal stages with SnowSQL command line, and what are the different types of internal stages, and what is the importance of put command and get command. We'll try to see, and what the copy into command also we need to understand. And then we'll try to see what are external stages and how to load the data from S3 bucket to Snowflake. So internal stages will help us to copy the data into Snowflake environment, and from there we load into the table. That we will do only if we don't have any Snowflake account, any cloud account like AWS account or any Azure or GCP. If I have a cloud account, then I can use S3 bucket as a storage. In that scenario, we will create an external stage. So how to create external stages, how to load the data from S3 bucket to Snowflake, how to unload the data back to S3 bucket or internal stages, all we will learn in this particular module. And then we'll try to see in deep about different types of file formats and what is the variant data type and how every type of file can be loaded with a continuous loading, and we'll see first with the bulk loading and along with the continuous loading with Snowpipe also. So the next model is the same. We will try to see how to load the data into the Snowflake environment using Snowpipe with continuous loading. We also will try to see what are external tables and directory tables, how can we go and leverage them to manage the data in the stages. And the next one, partner connect. This is going very, very important chapter to understand how Snowflake can be integrated with other partners. So I can integrate with Python, I can integrate with Power BI, I can integrate with Matillion, DBT, many different tools are there. How to go and manage Snowflake data from those particular tools. We will learn all those connectors from this particular module, and how to access Snowflake data from these tools. The next one is scheduling. Scheduling and incremental loading. We will try to learn that as part of this module using streams and tasks. And the streams and tasks will help us to perform the incremental loading, and to automate the incremental loading we use task. And the slowly changing dimensions, SCD type 1, type 0, type 1, type 2, we'll learn all this as part of this particular module. And also we'll see how to schedule the incremental loading weekly, daily, monthly, all we'll see by using task. And also we will try to see how to automate these particular tasks using stored procedures also. And we also should know about what is the replacement of this particular streams and tasks, that is dynamic tables. So we will learn about dynamic tables also. And once after we finish that, we'll jump into the secure data sharing, which will be part of data governance. So data governance is also very important topic for Snowflake data engineers. So how to share the data with other Snowflake and non-Snowflake accounts, and what is a reader account, and all this stuff we'll learn in this particular module. And apart from that, cloning which is important topic, how to go and create multiple tables by cloning, and how to save the storage cost. So we will try to learn about that particular cloning, are also called as zero copy cloning, in this particular module. And the time travel and fail safe is also which is important as part of database backup and maintenance. So we will try to see how to restore the deleted data or dropped tables, and how to what is time travel, how to implement it, and what are different ways to restore the data, and what happens if my time travel period will be expired, and my data will be moved to fail-safe period also. So what is fail-safe period, and what is the relation between fail-safe and retention period, all we will discuss about in this particular module. And also what are the different types of tables available, temporary tables, permanent tables, transient tables. We will learn all this as part of this particular module. And finally, we also have Snowflake views available, so which will be going to help us to create normal views, meta views, and secure views also. This will help us to mask your actual tables and provide us a restriction of accessing the main tables, and it will help us to hide your tables and use views to secure your data. And we also have clustering and performance tuning, which we'll try to learn, and what is clustering and what is micro partitioning and how to automatic clustering can be applied while creating the table. What is cluster key, and what a cluster key is nothing but similar to our index in normal databases. And we need to understand what is the best way to choose the right column for the cluster key. We will discuss all these particular topics in this module, plus Snowflake Python connector, which is very, very important, and Snowpark. These two are very, very popular in the market now. How to manage Snowflake by using these two, what companies are looking for. If you know Python and Snowflake and Snowpark, you can reduce so much amount of effort and cost. So these two topics I was not discussing in detail in other batches, but the most recent batches, I started adding these two modules also in deep. And how to go and integrate Snowflake with Python, and how to integrate Snowflake with Snowpark API. So this will save so much amount of your cost and time. So we will try to learn this particular two use cases with some end-to-end data pipelines. So every topic what you are going to learn will be with use case, not like topic which you will learn and will leave that. You will definitely learn with some use case, how it will be used in the real time, and what I also provide some assignments where you need to work on and come back and submit assignments every day, because if you don't explore the things, you can't learn. So assignments which I'm going to submit, you need to work on. If you don't work, you can't learn. That is what I usually advise the people. If you are learning something, learn with some effort and be focused, because you are spending your time, which is more than money. So always try to learn the things, and once you learn and then do 2 or 3 end-to-end projects, you will definitely will be going to get a very good job, because these particular topics which I am covering here, most of them are I used. Most of my projects I'm still using. So even Python and Snowpark also I'm using since almost 10 years, but I never taught in deep about all these topics, these two topics in other batches. And the Snowflake user-defined functions and stored procedures also we need to understand. We'll discuss about them as well. And DBT and Snowflake integration. This is also one of the tool which every company is asking now. How to automate your data validations and data quality checks and data pipelines using DBT and Snowflake. That is also one of the important feature. Every JD you can find it. Snowflake with DBT is very popular. So we will learn about what is DBT and how DBT can help us to apply some transformations, and how to create an end-to-end transformation pipeline using DBT and Snowflake, and end-to-end Snowflake DBT project also we'll discuss about. And finally, what is Airflow, and how to integrate Airflow, Snowflake, and DBT combination also is a very demanded feature now. So we'll try to learn how to integrate, how to automate the DBT transformations with on Snowflake with Airflow, and we'll try to see one use case also with all these three. And finally, we'll do some projects which will help us to go and explore more. All these particular projects we will try to do one by one. I'll share the code also. I have the documentation code, everything. If at all you want to add any of these projects in your CV, you can even add. So most of them are almost real-time projects which is simulated. So you can also use most of them, and you can even add them in your CV if at all you want. So apart from this, I also will try to help you if at all you want to go and apply for certification, and also any CV guidance. And daily class will be recorded, and the recordings will be available in the Google Drive. Plus you will get all the materials, assignments, and daily you will have a quiz which you need to go and appear and submit that quiz. And assignments also have to submit, and hands-on scripts also I'll share you, which you need to work on. And for every 2 modules, I will try to give you an assessment like a multiple choice questions which you can appear and test your knowledge also. And plus, additionally, I'm sharing the Snowflake dumps also. So this is not I'm doing with all other batches. Since 2 or 3 batches only, I'm doing all these Snowflake dumps and going with this quiz and assignment submission. I'm going in deep because I want everyone to focus. And once in a while, I also go with some working sessions. If anybody wants to like demonstrate something which they did, I'll give a chance to even go and like project that. You can also project. And any new feature you find in Snowflake, you can go and come and show to the team so that everybody will know that. I have a habit of any new feature I find in Snowflake, I'll go and test it and submit to my students. If you also need to keep that habit. If you find any new feature in Snowflake, try to test it and then post in the group so that everybody will know. So that it will be helpful for you as well as others. So that particular like way how you have to learn the things, that approach, that habit you should have. Then only you can explore the things fast and try to keep learning. Daily you have to learn some new topic and new feature. You need to do some research and go to LinkedIn and you'll find so much like information about Snowflake people are posting. So you'll get so many like new features which even I don't know some features, because Snowflake is very a big ocean it is now. You'll get so much of documentation available, and we can't go every documentation and learn. Someone posted something with some examples, try to understand and try to implement and immediately and see that. I have a habit to do that. So I learned so many things by following that approach. So I also will share some like new feature which I find every time, and which you can also go and try to test it. And so let us keep a habit of learning together and help each and everyone and help each other, so that will become a collective learning. So any questions anybody have, you can ask me now. And this particular course duration is 40 days, 5 days a week, daily 1 hour, 6 p.m. to 7 p.m. is we have 3 batches, but I'm starting the first batch at 6 p.m. to 7 p.m. IST. I'm also planning other batches at like 8 p.m. and 9 p.m. also, but it will take some time. But as of now, I'm just starting the first batch as of now, this batch for this month at 6 p.m. only. I have monthly batches, but for this month, this is the first batch. Okay. Any questions?
So where can we find all these quiz and assignments which you are going to post every
Google
day?
Drive.
Google
You will
Drive.
have a
Okay.
separate folder. For
Okay.
assignment, separate folder. For every day wise, you will have the folder.
Okay.
In that folder, you will see assignment separate folder, a quiz separate folder, and material separate folder, and also
Okay.
and transcription separate folder.
Sure. Thank you.
You need to just try it. That's it.
Yeah. Got it.
And we submit it. I'll be very happy because I'll come to know where you're standing also.
Yeah,
Because most
that's
of the
right.
people will be busy, I know, but that quiz will not be like 50 questions or 100 questions. It will be just like 10 questions maximum. It won't even take 10 minutes also.
Okay.
Okay.
Okay. Thank you.
No problem. Any other questions? I can see Abdul, Satya, and Viru. You people joined. Sorry, I didn't observe you people. So Abdul, how are you? Abdul, can you hear me? Satya or Viru? Any specific questions from your side? Viru,
Hi, Sri.
your voice is a bit low, Viru.
Hi, Sri. Good evening.
Yeah, Viru. I hope you joined from this invitation from some group. So any
Yeah,
specific questions, Viru, do you have?
yeah. The Snowflake is follows shared disk or shared nothing architecture.
It is a combination of both. It's a hybrid architecture.
It's a mix of both, right?
Mix of both. It is a multi-clustered, like a hybrid architecture, which will go and manage with auto scaling automatically, and it is a multi cluster architecture, which is a combination of both. It's a hybrid.
Fine.
Yeah,
Fine,
no
sir.
problem.
Thank you.
Oh, yeah. So I hope Biru, Abdul, and Satya, I hope you people are new, right? I can see Pujita, I know Nikhil and Suhasini, and I hope you people join from some other group. If
Yes.
you are willing to join the WhatsApp group is there, you can just directly join into that group. And if you want more information, you can directly ping me also. And this particular course is basically a 40 hours course. We can assume 40 days, but it may go beyond like 40 to 45, like tentatively. But the end of the period, training is most crucial, because you are going to implement some projects here where you'll go and learn and implement what you learned most of the times. And then we will integrate multiple features together, and you will try to build end-to-end data pipelines, which will help you to explore more. But as you know, most of the companies are now using Snowflake as a database, and you will definitely get exposure to the whatever the like features that commonly used in the in the industry. So I am using Snowflake since almost 5 years. Whenever Snowflake started in the initial stages, I was there, and my journey with Snowflake is whatever I learned. All this, my experience is almost 5 years, 5.5, 5 plus years, you can say. And I'm a Snowflake architect now, as I started as a Snowflake developer. So I work as administrator, I work as architect, I work as a developer. I do in multiple different roles. So to learning this particular tool is very easy. If you know SQL, it's very easy. So I am going to cover some part of SQL also, 4 to 5 class on SQL part, and some people who are not familiar with SQL. So this particular 4 to 5 classes will help you if you are not sure about SQL. Got it? And Satya and Abdul, any specific questions, Satya? Satya or Abdul? I can't hear both of you. If you are speaking on mute. No questions, Abdul and Satya? Now Suhasini and Nikhil, how about you guys? Are you able to follow? Nikhil?
Yes, Sri. I would understand totally, but at this session, I don't have any questions.
Okay, you are able to
For
follow,
as
right?
of now. Yes.
Okay, cool, very nice. Suhasini, I hope this is a repeat for you, I think.
Yeah, I know.
So you are able to
Yeah.
recollect, right?
Follow. Yeah.
Okay, cool, nice. Uh, if you have no questions, then we'll close for today, and we'll connect tomorrow at same 6 p.m. and we'll continue the classes. And
Yeah, Srini,
yeah,
I have a question.
yeah, Viru, go ahead.
Yeah, so the people who don't know about that stored procedures and functions,
Mhm.
that will be also a part of Snowflake, right?
Yeah. See, Snowflake also
Yeah.
similar to other databases, right? ANSI schedule follows. Snowflake also have
Yeah,
stored procedures and functions, but stored procedures and functions in Snowflake, the difference is you can write in other languages apart from SQL. I can write in Python, I can write in Scala, I can write in JavaScript also, and I can also write in Java also. So this is not possible with the other databases, correct? No? If I am a Python
yeah.
programmer, I can write in Python also. If I am
Okay,
a, how much?
yeah, how much effect will be there for the people who don't know about stored
Effort
procedures
wise,
and
see,
functions?
nothing, I think, see, nothing is rocket science, huh? to be honest. If you know what is SQL, the basic SQL part, writing a procedure is easy. See, to know a language, first I will learn alphabets and then words, sentences, paragraphs, and then grammar. Then I'll club together, right? Correct?
Yeah.
Same like that. A language, SQL also a language, right? Structured query language. You need, if you know the fundamentals on what is what, so combining them and writing a procedure is not that much difficult, I feel, because it's like almost like writing a program by combining. Programmatically, you will add some program control statements and loops and other stuff. And most of the features are available, whatever available in other databases, we can find here also. Like cursors also available here. Dynamic SQL is available. People who know dynamic SQL, I'm going to teach that. Dynamic SQL also very popular now. So most of the projects are using dynamic SQL in Snowflake. So how to go and automate and dynamically creating the tables, dynamically altering the tables. So how to maintain the inventory of the tables and database objects. So I am doing that, and the people are doing that. So there are so many features and applications I built in Snowflake with Python and other features by leveraging. I'll discuss about all those stuff. Okay. Yeah, no problem. And I think Abdul and Satya, if people are back, you can ask any questions you have. Abdul and Satya.
Nothing, my side.
Okay, Satya, no problem. So Satya, are you able to follow the class?
Yeah.
Okay. Abdul, how about you? Sorry, I'm asking many times because I want to make sure that everybody got some learning today. Okay, anyway, so if you are able to understand today's class, we'll continue tomorrow and we'll try to see the Snowflake architecture and what are the different features available in Snowflake. Plus, we also try to see what are the different costs Snowflake will charge the customer. We'll see that, the pricing part. Okay. That's all for today. Thanks for joining today's class, and we'll continue tomorrow. And if you people, how like Satya, I don't know how you joined. And Biru, how you joined from some other group or Snowflake group?
Yeah, through Snowflake group only.
Okay.
So not specific from this group.
I see. Okay.
Yeah, they have posted me something.
Okay. That's fine. Satya, how about you? Okay. Anyway, you can just reach out to me if you have any specific questions, and we'll continue tomorrow. Okay. Thank you so much.